So the first thing we're going to do is we're going to go to GitHub and download the Fluidity Calculator macro. This you can easily do by clicking on code here and then download. Then close GitHub afterwards, but here you have the installation instructions and some notes. Then let me put it here on the desktop. What we're going to do next is we're going to go to the Finder to find the Fiji application, and then right click on it, show package contents. In Windows you just find the Fiji directory that you downloaded from the Fiji website. So here we're going to have to look for two folders. The first folder is the toolsets folder. That's on the macros folder. So here we go to macros, then to toolsets, and here we copy the two files on the toolsets folder, the calculator itself and the icons folder. Second thing, we're going to go to the LUTs folder and copy the GP Viridis LUT. Good, so installation is done. Once we install the tool, we can launch Fiji. Now, every time we launch Fiji, we will also have to load the tool, but this has to be done only once every session. And to do so, we will click on this double arrow here and just click on the name of the tool, Fluidity Calculator version 1.0 in this case. So this is the tool, and we'll try it on a sample image. This is spectral imaging data. Here you can see hex cells labeled with NR12A, and each channel of this image is emission wavelength that we connected. So in this case, for example, 610 nanometers. So we're going to click on the icon here, and this interface will show up. Here we can choose the wavelengths for channel 1 and channel 2. The number of channels we want each channel to contain, so to speak. So if we will combine more than one channel in case we have low signal. So here we want to keep this number as low as possible, and if the signal is good enough as in this image, we will use just one because it will give us the higher resolution. We can also apply a min filter during thresholding, not to the raw data, just to make thresholding smoother. And we can also choose the radius for that min filter and the channel we're going to use for thresholding, which we recommend to use channel 1 plus channel 2. Then we can also define a percentage above of which we will get a warning for saturated pixels, and then we can choose to show the emission spectrum or to show the parameter tables, for example, to save the results and to save these settings, default settings, if you want to do so. So let's press OK. We can save directly on the desktop, and then here comes thresholding. We will move this bar here to select the pixels that are in red for analysis. The rest of the pixels will be ignored, and then we can press OK here. Don't press any of these buttons, just press OK. And yeah, that's it. This is the raw image. This is the GP image, the fluidity image, color-coded Viridis. This is the histogram or GP values, which are also saved here in case you want to plot them using different software. This is the emission spectrum of all the pixels above the threshold, and this is the table to build this emission spectrum. These are the parameters we use in case we want to replicate the analysis, and these are the results.